Hey everybody, this is Larry. This is still me in Lisbon. Yeah, doing a lead code before the the fight, I guess. Today's problem is 864. Show this map to get all keys. Hopefully soon we'll return to normal schedule for a little bit. Okay, so this is a problem that I haven't solved before, so that's an exciting thing to do. Though maybe the name of the problem gives it away a little bit, but we'll see. So the shortest path to get all keys. Okay, so you have oh, just do it by doing. Okay. I didn't really read all the details, not gonna lie, because no one can read that fast. I kind of just skipped ahead. It just occurred to me to get all keys part, and then I saw the grid. I was like, this seems like it's gonna be what's it called, traveling salesperson problem or ham path or something like this. I guess it's TSP because ham path is unweighted, but yeah. So then I was like, well, that's not gonna be Gucci. And it's not quite that, right? It's to get all keys. Yeah. So, and I was like, well, in those cases, at least in the most general example, it's gonna be exponential, right? And if it's gonna be exponential, then the constraints have to be pretty tight. So this is why I scrolled straight down the constraint. I said, okay, well, if the constraint is 6, it should be okay. Okay. So basically, this 30 by 30 grid size, so that's going to be 900. 900 times 32 for 2 to the 6 should be good enough, right? What is that? That's like, well, that's less than 100 cube. Why did I say jump to 100? It is less than 100 cube, which is a million. So yeah, so we're doing good on time complexity in the number of states, and then we're only visiting up, down, left, right. So there's only 4. So then, so yeah, so that should be good enough for me to kind of get going, and that's what I'm going to do. But the idea is that you just basically keep state, right? So state, instead of just the location, which is X and Y, you also want to keep a set, say, a set of keys that you currently own, right? And a set of keys that you currently own, you can obviously represent them with a set, but I'm going to use bit mask because it's just more natural to me, especially for 6 items. There's at most 6 keys, and the locks don't really matter. You just have to acquire all the keys. You don't have to acquire all the locks. It's just that the locks determines where you can go, right? At least that's my understanding. So yeah. Oh, and in fact, that's the explanation in example 1. So yeah, so we're pretty good here. So yeah, let's see, what is the other thing? So this is a starting point. So we can do something like just to parse the starting point. Right, and then I guess that's the only thing we need. And the keys are A B C D E F. And A B C D E. I just go up to F, right? So yeah, and we have to try to determine how many keys. Okay, so I mean, for number of keys, is the lowercase or uppercase? Okay, lowercase is keys, so then we can just count the number of keys. I think keys is not a keyword. That's actually maybe surprising, but you probably can write this a little bit cleaner, but it's fine, I think. You only do that all the time, C times anyway. Okay, so that's the number of keys. So then, yeah, so then we start with a breadth search, really, on this new graph of X, Y, and keys, right? So yeah, so key is equal to oops, would be better. Would be good if I could type it correctly. Right, and I mean, you know, and this is just what, but we also want to set up, you know, like a distance thing. Multi-dimensional things always kind of is a little bit tricky, it seems like, in Python, and I always have to like just be a little bit careful. But yeah, okay, so now XY keys without going mask is equal to q top left, right? And the distance is equal to best of XY mask. Oops. It would be helpful if I could type the M. Okay, thank you, M. But yeah, we'll set up the directions, which is still up, down, left, right, right? And then yeah, yeah, I mean we can, if mask is equal to, and this is just 2 to the power of keys. That's really what it is. And this is 2 to the power of keys of -1. As I said, I'm using bitmask. I'm not going to go over bitmask in this video, but suffice to say that it is basically a representation of a set, right? Basically, each bit can be true or false, representing whether the corresponding letter A to F is, or the key A to F is, that we acquired it, right? So yeah. So we have right? And x and y is equal to x plus dx, y plus dy. And then the new mask is equal to mask if, well, let's make sure that it is within bound first. Then maybe we'll move the new mask this way. And then if, where's the grid of nx and y? Now we have to do some maths, or not maths, but just parsing, say. Right. So if this is a key, then we just obtain it, so that's nice, right? Yeah. Maybe when you what do you call it? Key string is equal to A, B, C, D, F, right? Right. Okay. Right, and then otherwise, and oh yeah, lock string, which is just, I mean, I'll type it out, but you can also, you know, use your imagination on how to write this a little bit better. Okay, so if grid of nx and y is in locks, and so this is the index, right? So if mask, so if we have the key, then we can go. If we do not, then we cannot go, right? So that means that if this bit mask is equal to 0, then we have to continue. We cannot. Well, hopefully that's right. I mean, don't take. I mean, you're seeing what I'm doing live, and if you watch enough of it, you'll realize that I make a lot of mistakes. So don't, yeah. And then now that this is all good and done, we can do the BFS part, right? NX and Y and mask, and then best of NX and Y and mask is and mask is equal to D+1, and then wait, and we return -1 if it's not possible. Yeah. Oh, I forgot the other thing that we have to terminate, which is that the walls, right? Obviously, is you go to continue, right? Oh, I forgot to define infinity. Too many things going on in this head of mine, and not all in focus. This looks good for these 3 test cases. Is that good? Are we Gucci? I don't know. Let's give it some. I think the idea is right. Maybe we have some implementation silliness. Oh no, it's going to time out because we didn't terminate early. Okay, fine. Let's take a look. Why is that? Why does that time me out? Oh, I'm dumb. I forgot to do the breakfast search part. That is a critical part. Wow, noob mistake here. Oops. Noob mistake here, right? So if D+1 is less than best of NX and Y and mask, then we do this stuff, or alternatively we can just do the opposite of this. Wow. Larry doesn't know how to do BFS as we were talking about, right? So somehow I got the other ones correctly, but yeah, there you go. Maybe I went a little bit, I wouldn't say I went a little bit too fast, but I was just, there's a lot of things going on, so it's easy to forget things because I forgot, like this and this and this and this, and there's like 4 things to do though. That one should, right? But yeah, what is complexity here, right? It's going to be O of R plus C, but with another factor. But I'm just going to say that first. So this is R times C because that is, breadth search. That's the number of cells. That's the number of nodes. That's the number of edges, because number of edges is 4 times whatever, kind of, right? But it's also going to be times 2 to the K, where K is the number of keys. And this is not just on here, is that the way, yeah, I guess. So yeah, that's pretty much it. That's the time and space in the worst case. Though I think a lot of those states are not visitable, so you can maybe make some optimization based on that. But yeah, that's all I have for this one. Let me know what you think. Stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye.